about roots and zeros part 2. So just like we did in completing the square a minute ago, kind of our warm-up activity, we got 2 plus 4i and 2 minus 4i. Those are roots to that quadratic equation. Correct? All right. So let's do that in reverse. This time it's telling me, okay, let's get through this. Write a polynomial function of least degree. Least degree means why would you say 3? Okay, you're right. There's 3 zeros to this. So there's going to be, the least degree would be 3, right? A third degree polynomial. Okay, so write a polynomial function of least degree with integral coefficients. Coefficients that are integers, right? The zeros of which include -1 and 1 plus 2i. Okay, so let's break this apart. It's telling me what my zeros are. What are my zeros? -1, 1 plus 2i, and there's another one there that they don't have shown. 1 minus 2i. For some reason, they feel like they don't want to spend any more ink, I think, because it's automatically assumed from the complex conjugate theorem, and I'm not going to state the theorem to you, but basically says if you've got a 1 plus 2i, you get a 1 minus 2i, right? Whenever you have an I, don't you always end up having a plus and minus? Yes. Okay. So those are my zeros. Let's talk about our factors. So f of x equals, how do I normally write this one? It would be x plus 1, correct? I'm going to write these in brackets because this is going to get a little bit complicated. It's going to be x minus and x minus, correct? X minus this whole thing. I'm going to put in parentheses. 1 plus 2i. 1 minus 2i. That's our first step. Write the factors. Second step, regroup. All right, so I'm going to regroup this. I have an x minus, I'm going to distribute this negative, and at the same time, I'm going to regroup the x and the 1 and get the 2i by itself. But when I distribute that negative, this is going to become negative 2i. And this is going to be positive 2i. I'm going to stop right there for a second. If you get to this step, it will, no matter what, will match. Those will match, and those will match. I have a negative and a positive. What does that look like? I heard it. Difference of what? Difference of 2 squares right there. Okay, whenever you have something that's really abstract like that, oops, it's because I walked away from it. All right, whenever you have something really abstract like that, I would put something familiar as an example. Like, let's use a highlighter and show what's common with these two. My x's would be right there. And my constants would be right there. See how they match? And the only thing different between them is plus, minus, plus, well, minus and plus. Can you see it? Okay. Next, I'm going to rewrite it as the difference of squares. First, this is grouping. I discover, oh, this is the difference of 2 squares. So I'm going to write it like that. When I write this as the difference of 2 squares, it goes like difference of 2 squares, where what goes in, this is my pink, and this is my green. This would be and this would be 2. So I'm going to do the same thing here. I have the difference of 2 squares. Where my pink, oops, my green goes here, and the pink goes here. So what goes here? X minus 1. And what goes here? Just the 2i. See that? Because the negative sign is here, positive sign here, just like negative and positive, positive and negative. Okay, so after that, I just need to simplify, and this is where it kind of gets a little bit mucky. This is a perfect square trinomial, or x minus 1 times x minus 1 minus, this is 2i squared, which is 4i squared. Are we good so far? You have to be nice and organized with this. X plus 1, x squared minus 2x plus 1 minus 4 times negative 1. We'll make sure we do all of our steps. Equals x plus 1 times x squared minus 2x plus 5. What could I use now? You don't have to. I would. You can catch errors really easily this way. Earlier in the day, I caught myself I made this negative 2x instead of x squared. Watch what happens. We'll just leave the mistake there. And I did the same thing right here too. Check this out. This is x cubed. Then I said x squared and, oh, yeah, they don't, wait, why, they should match, right? Oh, I forgot it. If I would have done that with traditional foiling, I would have never caught that. I would have just kept going on. All right, so this is actually x squared and negative 2x squared, which is negative x squared. This should be a cube. Spending too much time trying to catch mistakes. I'm making mistakes. Negative 2x, I did it again here. See that? Oh, they don't match. Oh, that's because I forgot my x. Negative 2x and positive 5x is positive 3x plus 5. There's your answer. Write it down from the beginning. Okay, so try this one on your own, and I'll go through steps as you go to make sure you're setting it up correctly. All right, so I'm going to start this out with my zeros. My zeros are 4. 4 minus I, and 4 plus I. Therefore, my factors, f of x equals x minus 4, bracket, x minus 4 minus I, and bracket, begin another bracket, and x minus 4 plus I, and bracket. Now my next step is to, it's up there, regroup it. Okay, so I have, Josiah, please turn around. So I'm going to regroup it to x minus 4, it's going to become positive I, and x minus 4 minus I. Now I have the difference of 2 squares. Okay, I'll pause. Okay, so now that I have the difference of 2 squares, I'm going to write, excuse me, thank you. I'm going to write my brackets for my difference of 2 squares. And be very careful to write in here what goes in my first bracket. X minus 4, and my second bracket, I, x minus 4. Now I'm going to break this apart. X minus 4 times x minus 4 minus I squared, which is x minus 4 times, I might as well just use parentheses now, x squared minus 8x plus 16 minus negative 1. I should have used a bracket. Equals x squared minus 8x plus 17. How you guys doing so far? Good? Can I keep going?
No, not good.
Because you stopped. You have to continue. Get myself an area model. That'll work. See that, Alexis? Not perfect. I'm okay. X minus 4, x squared minus 8x plus 17. There's always room for improvement. Okay, so this is x cubed. Whoa. There we go. X cubed minus 8x squared plus 17x minus 4x squared plus 32x squared should be x. Thank you, caught it as I said it. 32x and 68, negative 68, equals x cubed minus 12x squared plus 49x. Can you read his paper pretty good, Josiah?
Yep.
Okay, good. All right. There's your answer. Did you catch where you missed? Question. Can you do this on your own? It's going to take practice. Okay. I distributed. X squared, negative 4x, positive 16. It's a perfect square, and those are, I mean, I could have foiled it, but it was more work. Most of you are used to, you could, yep, I just distributed. All right. So I'm not going to go over what we learned today, but I am going to go over your closing thought with you. This is we're going to do all this tomorrow. Okay, guys, let's just focus on this. I meant to open that in another window.
I like to tell myself all this stuff.
Okay, on your assignment sheet, I need to find blank roots before solving this polynomial with another method. Why 3? Hold on, let him talk. Guys, he's the one who answered. Go ahead. Say it again. Why would I need to find 3 roots before solving this a different way?
I feel like I want to say 3 zeros.
That's exactly right. If you've got 3 zeros, right, then you'd have x squared plus something, right? Because this one would drop it down to a 4th degree. This square, this 0 right here would drop it down to a 4th degree. Then once you found another 0, that would drop it down to the 3rd degree. Then you find another 0, that would drop it down to squared. And once you've got squared, you can now use other methods. So you need to find 3 roots. How would you find those 3 roots? No. Sign changes would help you, right? Because then you need to start using what? What do we use when we've got numbers that are this big?
Grouping.
So, is this what we did?
What do we found the Descartes rule told us how many we could expect in the positive and negative direction, but then we used that to do what? Synthetic division. Nice. Good job, guys.